Lesson 21. We're looking at section 7.3 now. This section is titled Vectors. Okay. What is a vector? A vector is a directed line segment. Okay. If we look very carefully at this definition, it is specifically a line or what looks like a ray, okay, that has a given direction. We generally refer to the length of the vector as a magnitude. Okay. It is how long that vector is, or how fast the object that we're talking about is moving. Okay, so we have a direction and a magnitude. A direction and a magnitude. Now, the direction of a vector is measured by an angle measure. So all the work I'm going to do in this section, I'm actually going to do directly on this note paper. Okay, so the direction of this vector u is specifically the angle measure there. Okay, just like the direction for this vector v is really that angle measure there. And I'm going to call this phi or phi, and this theta. Okay, this is the vector v. This is the vector u. Okay, the magnitude is specifically the length of this vector. The magnitude of v is specifically the length of that vector. Now, to get a little bit of a emphasis down, what looks like the absolute value of u, this is referred to as the magnitude, okay, of u. Again, so the absolute value of v would specifically be the magnitude of v. Okay. Now, sometimes when we use notation, and I'm going to use this notation regularly, is the u. I'm going to put what looks like a little arrow above it. That's going to denote that this u is a vector. Same with this here. Okay. Now, in these problems, they didn't do that. They didn't say that this was a vector u, but we're going to assume because it's labeled and it's got a direction, okay, that angle measure, and a length, it's actually a vector. So, what happens when I add u and v together? Okay. Now, mathematically, this stuff is actually very geometric. It's very visual. It's not difficult for us to do. Now, what I'm going to do, okay, is I'm going to pull out another piece of paper, and I'm going to mark this up for the length so you can see how I'm doing this. So from here to here is the length of u. I'm going to try and keep this consistent as I drag it down into this section. Okay. So, give or take, as long as this is correct, that is the vector u. As best of my ability, just copied right down there. I'm going to do the same thing with v. Now, v is going to sit here, and it's going to be from length there to there. Okay, again, I'm going to do it on another piece of paper just this side and mark that up to there to there. And what I'm going to do is I'm going to try and drag this down without changing the angle at all. If I can do this correctly, it will look exactly like we need it to. This is that vector copied right there. Now, I'm actually going to put the notation there for u and v. Okay. What is the vector u plus v? Well, if I attach what we would call these vertice points here together, and I recopy this, I'm going to do the best of my ability to draw this appropriately. Let me see if I can do this one as well. And I screwed it up. Okay. Where's my eraser? There it is. If you notice, when I connect these and I draw those dotted lines, I have created myself a parallelogram. Okay. Really, this v, I've copied it here as well. And this u, I've copied it over here as well. When I do that, you'll notice that right in the middle, and I'm going to draw this in, where is red? Right in the middle is this thing right here. Okay? And you'll notice that technically I have taken u and I have added v to the end of it. I have taken u and I've added v to the end of it. That's u plus v. This vector in the middle is u plus v. Okay, it is that whole vector. Likewise here, this is u plus the vector, sorry, this is v plus the vector u. V plus the vector u is actually the same thing as that thing. Okay, that's very important to be able to recognize. So right here, this red line is u plus v, the vector u plus v. Let's move down to negative v. Okay. What is a negative v vector? Well, v is this thing right here. Okay. I'm going to copy that down here again with the same piece of paper I had before. There to about there. And I'm going to move it over. Give or take, I think that's not as straight as I'd want it, but that's v recopied appropriately. Okay, and again, we're just trying to get the idea of the visual representations down right now. We're not too worried about the mathematical setup. Okay, just the visuals. What is negative v? Well, negative v is actually taking this vector, and negative says go in the opposite direction. That's all it says, go in the opposite direction. So instead of traveling over to this point right here, I'm actually going to travel the exact same distance, and I'm going to go ahead and pull this paper back out one more time so I draw the correct distance. That is negative v. Okay? It's just the exact angle, or the exact vector just rotated 180 degrees, okay, or flipped in the opposite direction, okay. Well then, what would u minus v be? Well, why don't we avoid dealing with the difficulty of saying, well, how does it match up to u plus v? Why don't we just do u, take v, and flip in the opposite direction? Okay, so I'm gonna do this very crudely. I'm not gonna do it perfectly. That there is u. Sorry. That there is u. Okay. V is supposed to go like this. But I don't want to add u and v. I want to add u plus a negative v. That's the concept. So let me take this thing and flip it to go backwards. It's there. So I did u plus a negative v. And therefore the vector that I'm looking for is this one right here. Okay, that is the vector u plus a negative v as a vector, which is really just u minus v as a vector. Okay, it's that one right there. It's just taking u and taking v and making it negative, so it goes in the opposite direction. And then I just do u plus that negative v. From this starting point to that ending point is my vector u minus v. Again, that is the image representation of vectors. Let's talk about the setup for if I were to looking at a components, the x and y directional lengths. Okay. What we mean by that is that every vector that I play with can actually be plotted on the xy coordinate plane. The grid below to draw this vector. Now this vector has an x and y coordinate piece to it. All we're saying is that negative 4, 7, that's really the end point. So negative 4, 1, 2, 3, 4, up 7, 2, 4, 6, 7. Okay? So every vector, looks like this, is going to have a length and a magnitude. Well, let me rephrase that again. Sorry. It's going to have a direction and a magnitude. My point with that is, does it matter where it lands on this grid? The answer to that is no. As long as I have the appropriate length and the appropriate direction. Okay, now, in this case, this vector is denoted as negative 4 units of x, positive 7 units of y, and I draw the line, as best to my ability, straight. That vector, make sure you put the arrow on the end of it, is the vector negative 4, 7. Notice the different denotation. The vectors have these pointed, okay, setup. Now, your textbook might actually use different notation. This is the notation we're going to use in this class. This is the notation that every mathematician uses as you go further along in mathematics. So, let's go ahead and continue on. We're almost done with most of these notes. The information is actually not that difficult, as long as we understand that a lot of this stuff is just visual. It said use the grid also to draw a vector between the 2 points 2, negative 1. I'm going to go ahead and draw this in red. 2, negative 1, okay, and negative 2, 6. So negative 2, I'm sorry, this is 2, negative 1. I don't want that point, as I can't plot points. 2, negative 1 is here, okay, and then I want to go negative 2 up 6. 2, 4, 6. And I want the vector between those 2 points. So I'm going to go ahead and draw that vector between these 2 points. As best of my ability, a straight a line. Now notice something about this, okay? Those 2 vectors look very, very close, okay? And this is A and this is B, okay? So it is going from A to B. Let me do this. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. In the coordinate plane, these vectors look similar. In reality, when it says number 6, explain how the 2 vectors are related, we will call those vectors the same. Okay? Yes, they have different starting positions. Okay? But in reality, the vector is only denoted, okay, or defined as a length, which we refer to as a magnitude, okay, and a direction. But if it's defined by a magnitude and direction, the magnitude of this vector is exactly the same as the magnitude of this vector. And the direction, if we look at the angle measure, is the same as the direction would be here for that angle measure. Again, if you look closely enough, let me go ahead and do that one more time. The magnitude here to here and from here to here are the same, and the direction has the same angle measure. Okay, is it coming from the x-axis theoretically here, and from the x-axis here. These 2 vectors are defined in the exact same way. The only difference is their starting position and technically their ending position. Okay? So it doesn't matter where we draw vectors, except for if we're told to draw them in a certain starting position. These ones are just easier for us to start at 0, 0 and draw to that point. I could have started somewhere, moved over 1, 2, 3, 4. I'm going to go ahead and actually do this. I'm going to start here. 1, 2, 3, 4, and up 7. 1, 2, 3, 4, 5, 6, 7. And that, from here to here, is actually the exact same vector as those 2. Okay? Keep that in mind as we work through these.